Okay, hi everybody, it's Miss Sinclair. Dominic just reminded me I didn't turn the video on yet. April 28th, 2021. A quick reminder, on Monday, we did what was called measures of center, which is the mean or the average, and the median or the middle. Today we're going to do measures of variability. So here's my first question. Who wants to take a stab at what do they mean by variability? Caleb, what do you think?
I think variability means like variety. Like there's a different variety of ice cream at the ice cream shop.
Okay, differences.
Or like tons of meat at the deli.
Okay, Peyton?
Well, I mean, like variety and then ability, so it's just
Able to be different. Able to differ. Good job. Who's that? Dominic, did you have your hand up?
Yeah. It's like a variable, many variables.
And we know variables are unknown and they change. Brooklyn.
There's a variety of different kinds of candy.
Yep, exactly.
Like the chance.
Yes, very good. All right, so variability. Here's the way I'm going to explain it to start with. If I grade a quiz and everybody in the class gets either an 8 or 9 out of 10, the data is going to be all squished up, right? Because it's all going to be here. But if I give a quiz and the lowest score is a 0 and the highest score is a 10, it's going to be more stretched out. So what we're talking about with variability is how far stretched out is the data from the center. So that's why we had to learn the center first. Now I want you to skip down 5 lines and watch what I do next. 1, 2, 3, 4, 5. 2, 3, 4, 5. And write this list of numbers. And I left a space up here because we're going to draw on this. So when you do measures of variability, we're looking at how stretched out is this data from the center. So the first thing we have to do is find the center, which is the median, right? So let's find the center. And then do this. The center number was 58. So draw a line like that. Now I want you to go up here on the higher scores and find the center of this. What's the center number up there, Tyler? You are in class now, right? Ethan, who sits next to you? Okay. What number's in the center? Huh? No, listen carefully to the question and don't tell them the answers, please. What's the center of this top half? Yeah. So draw another line. And Jason, what's the center of the bottom half? Yep. Okay, here's where the drawing starts. Ready? Any of you guys in STEM? This might look familiar. What do you think it's going to be? Can't remember? There you go. There's the box. And here's one whisker. And here's the other whisker. That's what I'm planning to do. Okay, all I want you to do is draw with me first. All right, so what we have created is 4 equal data spaces. So what is another word for 1/4? Quaid?
2/8.
Yep, that's not the one I was looking for, but yes. 1/4. So watch this. This down here is 1/4. This box right here is 1/4. This box right here is 1/4. And that tail up there is also 1/4. We created 4 equal-sized places. These two together make up 50% of all the data. Half of all the data lives inside the box. Not writing anything down, Dominic? You got a back of the paper? Turn that over. Oh, look, there's a place to write. On the back. All right. At least pretend to. Okay. All right, so what we've created are 4 quartiles. Because a quartile is a fourth. So quartile, 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 quartile. This part is called the inner quartile. And what it does is it tells us what scores are in the middle 50%. So what I'm going to suggest is you circle the top, the upper quartile number, and the lower quartile number. So this one is the lower quartile. See why we left spaces in there? The lower quartile is the lowest half. What do you think this one's going to be called? The upper quartile. And here's what we're going to learn about today. This is a crazy vocab word, so write this down carefully. The inner quartile range. That's a long word to write. So sometimes they might just say IQR, inner quartile range, IQR. And what they're asking is, what's the range of the top and bottom of these quartiles? Remember, the range is the difference between the highest and the lowest, right? So they want to know the range of the inner quartile. So we would do 70 minus 50, and that means the range is 20. There's a difference of 20 within those 2 middle quartiles. So that's kind of the gist of it. So set this over to the side now. Let's go back to this worksheet. I wanted to show that to you before I just asked you to write words in. A measure of variability. And we said variability was differences, or how things can be different. It's a way of describing how spread out the data is. So if everybody on the quiz got 8 or 9, it's only spread out like this far. But if the scores were all the way from 0 to 10, it's spread out this far. So we want to know, is it squished in together or is it spread way out? It can also be described as how much the data deviates from the center. Who knows what the word deviate means? Anybody want to take a stab at that? Yeah.
Like moves away from the center?
Yes, exactly right. That's exactly right. Good job. How far is it away from the center? The inner quartile range is what we just practiced in your notebooks. And here are the 4 steps that you take to find the interquartile range. So the interquartile range is a measure of variability that splits the data into 4 equal-sized quartiles. And you can see those 4 if you look at the picture you drew. It represents the middle 50% of the data. So here are the 4 steps. First of all, you can't find the middle number if they're not in order from least to greatest, right? Because you just have random numbers, you would just end up with a random number. So the first thing you have to do is put them in order from least to greatest. And then you find the middle. What's the word we use for finding the middle? What is it, Peyton? No, that's the average. The median is the middle. They both have D's in them. The mean doesn't have a D, so middle. Find the median of the lower and upper quartiles, which we drew a picture of. And then you subtract them to find the inner quartile range. So I'm going to refer back to this picture. Whoops. Thanks. So what they're saying is your numbers have to be in order from least to greatest, and then you find the middle. And then you go down here below there, and you see what's the middle down here, what's the middle up here, and then you basically subtract those 2 numbers. Okay? So that's what we're going to do. We're going to practice one of these together, okay? So remember, right here are the 4 steps. The data set below represents the different costs of a camera at an electronics store. Are they in order? No, Katie says no. So write the data from least to greatest. So the cheapest camera I can buy is 28. I'm going to cross them off as I go to make sure I don't miss any numbers. So go ahead and finish that, and then check and make sure I didn't miss anything. Does that look right? So we put them in order from least to greatest. What's the minimum price? What's the cheapest camera? Kaden? $28 is the cheapest one. What's the maximum price? What's the most expensive one? Ashlyn? $108. What's the median? So now we've got to go back and find the middle, right? There's the middle. So we're going to draw a line through that. Then you're going to find the middle of the upper quartile. And you're going to find the middle of the lower quartile. And you're going to make your box. And don't forget, these are the whiskers. Yes, sir.
I put my numbers right underneath the A, so I can grab it.
Okay. Okay. So what's the median price? The very middle was 59. What's the median of the first half? What's the median down here? Was 36, right? And the median up here was 71. Then you have to subtract those 2 numbers. So 71 minus 36 is 35. So the interquartile range is 35. So whenever you see the word range, it means the distance apart, right? From the highest to the lowest. So the interquartile is the box itself. Yes? No, because you got to borrow from the 7, right? Okay, what do you think of that so far? Hold on to your hats, because this only gets crazier. So we're going to go back in your book because I want to show you some stuff before we just start writing random things in. So check out this one. And again, remember, my job is just to introduce this, not to make you, professional mean absolute deviation finders. The mean absolute deviation. Now, the mean is not the median, so it's not the middle. What is the mean? What is the mean? We studied it on Monday. Quaid. Parker. The average. So you add them all up and divide by how many scores, right? And we said the deviation is the difference. How much do they differ from the average? Does that make sense why they write it that way? How much are they different from the average? So there are 4 steps to making sure. Oh, and guess what? They have a little acronym for this too, because who wants to write mean absolute deviation all the time? You know what they call it? Yes. So whenever you want to get mad about math, let me know. We'll do some mean standard deviations.
Someone's not walking me. I want to get mad about that.
Okay, there are 4 steps to finding this. So let's write down the steps before we practice it. The first thing you do is find the mean of your data. So remember, you add them all up and divide by how many scores you have. Step 2 is you're going to find the difference. Who remembers what math term difference means? Aiden. Subtraction. So we're going to subtract each data point from the average. Then you're going to add up all those differences. And then you're going to find the average of those numbers. It sounds really complicated, and that's why we teach this more than one time. So my job is this. My job is to go, so you're in Mr. Albright's 7th grade math class next year, and he says, so did you guys learn about mean absolute deviation? And you're going to go, yep. And he's going to say, what do you know about it? And you're going to go, it's confusing. Okay? So the whole point is that you begin to recognize, this is just like earlier this year when you guys for the very first time did positive and negative numbers. Now, no big deal. But originally, it was a whole totally different thing you hadn't learned before. So this is kind of where we're at with this. So let's go back now. You can put that away. And let's do some practice, okay? So I wanted to show that to you before we just start putting random words in here. The mean absolute deviation, or MAD, measures the spread of the data in relation to the mean. So we want to know, according to the average, where do all the other scores show up? It's kind of what we're trying to figure out. So the first step is you get the mean of the data. The second step is you find the difference, that's that subtraction part. The third step says take the absolute value, and I'm going to explain what they mean by that in a minute. So don't worry about that right now. And then you're going to total up all the deviations and divide by the number of scores. So you take an average, you get all the differences, and you take a second average. So what you're doing when you get the second average is you're seeing how close to the average are all of those scores. Are they far away from the average, or are they really close to the average? If the mean absolute deviation is close to 0, it means that most of the data values are close to the average. Just a fancy way of saying how spread out are the scores, with a lot of big words. So we're going to practice one of these. It's going to be in this table right here. It says 7 different students were asked how many members are in their family. The data is used to complete the table. So I have 7 scores, and these were all the data points. So I have to find the mean of the data points to get started. So who remembers, how do you find the mean? Somebody besides Quaid and Peyton. They're helping you. They're carrying you guys today. All right, Dominic, what do you got?
Okay, so you add all of the numbers that are in
Oh, yep,
numbers,
yep.
and you put it up where it says
You're almost close. You add up all the numbers and then do what's the... Not subtraction. Nope. To find the mean originally, you add up all the numbers and divide by how many numbers you have. Okay? So let's do this together. Ready? 3 plus 2 plus 4 plus 2 plus 5 plus 3 plus 2. I get 21 total. And then I've got to divide by how many scores I have. Divide by 7. The average or the mean of this data set is 3. So what it means is most of these families, if I average it all out, the number is going to be 3 family members. Now here's the subtraction part and why I said don't worry about absolute value. Put that down, please, Ashlyn. We're doing math right now. So what you're going to do is subtract these 2 numbers. 3 minus 3 is
0.
3 minus 2.
1.
Well, yes, but who said -1? Yes, but here's the point. As soon as you take the absolute value of -1, what does it become? So that's why if you just take the big number minus the small number, you can eliminate the absolute value part. 3 and 4 has a difference of 1. 3 and 2 has a difference of 1. 3 and 5 has a difference of 2. 3 and 3, 3 and 2. So we total all those up. 1, 2, 3, 4, 5, 6. Now to find the average of that, I'm going to take 6 and divide by the number of scores I have. How many scores do I have here? 7. 6 divided by 7, check that out.
Wouldn't it be 0.885?
Nope. Because of the 7, we're going to round up. Good job, Brooklyn. So let's practice one more of those. The number below represents the amount of time in minutes that it took Brianna to finish her homework this week. We have to find the mean of the data. So that's the average. So Dominic says, add them all up and divide by how many scores we have, right? So 15 plus 24 There's my total. And I'm going to divide by what, Dominic?
6.
So the average that she spent was 20 minutes. So here's where the difference comes in. So if the average is 20, on this night, she spent 5 minutes less than that, right? That's the difference. On this night, she spent 4 minutes more. 8 minutes less. 12 minutes more. 2 minutes less, and 1 minute less. So each night she was a little bit above or a little bit below the average. So the total absolute deviation, we add up all our numbers. And we get 32.
We didn't even see that.
Sorry. Add them up and get 32. And we're going to divide by what, Parker? Divide by 6. Whoa. You remember how to write those?
Yeah.
Whoops. You don't write it like that. The line goes over the part that repeats. Question 4. The following data set represents the number of cars running the red light at the intersection of Main and Avenue A over a period of 2 weeks. They want the median and the IQR. So median, so if interquartile range, remember that's when we line them all up in order from least to greatest. So let's do that first. Whoops, I missed an 8. I don't know, did I make any more mistakes? Did you guys get that?
211.
No, I missed the 8. I had to go back and squeeze it in there. Okay, so we have to find the median, the middle score. Ready? Oh, look at that. So what's the middle score going to be,
13.
Peyton? So 13. So the middle score is right here. Now we have to find the middle of the upper group and the middle of the lower group. And then you make your box. And here are the whiskers. I like the whiskers, even though we're not supposed to do them. It's so fun to do it. The middle number was 13. The interquartile range, remember? You take this number minus this number. How far is the range on the see the interquartiles range? Dominic.
9.